What's up everyone? My name is Pranav Sharma, and in this video we will be solving one Codeforce problem, and the name of the problem is desorting. So in this problem we have given a sorted array of length n, okay, and we need to do some operation on it, and we need to make this array not sorted or to desort this, right? And firstly we need to choose an index and add 1 till ai, and subtract 1 from ai plus 1 till an, okay, and this will be considered as our one operation, and we need to return the minimum number of operation that it will take to make the sorted array desorted, okay. In input format we need to take test cases as our input. In each test case we need to input the length of the array, and after that we need to input the number of elements of our array. Now let's check the example, what the problem is saying. For example, this is a sorted array that is given to me. Now first thing in my mind is that which array I will consider a desorted array or a not sorted array. I'll consider that array to be desorted if its ai element is greater than ai plus 1. Then only I'll consider that array to be desorted, yes or no, right? And according to the problem, if I am choosing some index, let's say this one, so in this part I'm adding 1, and subsequently in this part I'm subtracting 1, right? But we need to focus on only two elements. One is ai and other is ai plus 1. If this condition satisfies, then we will consider our array to be desorted. Let's say I'm taking this as my ai. I'm taking 10 as my ai, and 16 will be my ai plus 1th element, right? So we are adding to 10, we are adding 1 to 10, and we are subtracting 1 from 16, and it is common sense that after certain operation they will be equal to each other. They will be equals to each other after certain operation. Let's say if I am doing operations, after one operation 10 will become 11 and it will become 15, right? After second operation 11 will become 12, and 15 will become 14. After my third operation 12 will become 13, and subsequently my 14 will become also 13. So after three operation these numbers will be equals to each other, right? But they are not sorted. They are equal to each other, but they are not desorted, sorry, they are not desorted. So it took three operation to make ai and ai plus 1 ai and ai plus 1 equal. If I do another operation, it will make the array desorted. It will satisfy this condition, right? Yes or no? It will make ai greater than ai plus 1, which means that 3 after 3 plus 1 operation my whole array will become desorted, right? And 3 plus 1 is equals to 4. Now if I took ai to be 8, if this is my ai, then my ai plus 1 will be 10, and if I check after how many operation it will become equal, after one operation it will become 9, and 10 will also become 9. So it took only one operation to make ai and ai plus 1 equal, which means that this will took only 1 plus 1 operation to make the array desorted, which means that only two operation is needed to make this whole array desorted if I choose 8, if I choose this index. Yes or no? And I think 2 is the minimum number of operation in this. 2 is our minimum number of operation, and we will return this. Okay. Now the question is how I will find the number of operation that will make my ai and ai plus 1 equals to each other. It's very simple. If I do ai plus 1 minus ai and divided it by 2, I'll get the number of operation that will make my ai and ai plus 1 equal to each other. And in this I will add 1 and get my number of operation that will make the whole array desorted. And I need to find the minimum number of operations, right? This is the whole logic behind this problem statement. Now let's try to code this. Let's desort 1.cpp hashtag include tdc++. And in my main, firstly I'll input my test cases and apply the loop. Inside my loop I'll call my solve function, and the return type of my solve function would be void, and it will take no arguments or 0 arguments. In my solve function, firstly I'll input the length of the array and then I will declare a vector of integers. Let's call it ARR, and I will explicitly define its length. Now I will input this vector and after this to input it I will do cin ARR of I, and what I need to do, I need to find the minimum number of operation. For that, what I can do, I'll apply a for loop from int I equals to 0 till I less than n minus 1. So I am applying the for loop from 0 to n minus 2. I'll explain it later. Okay, so in this, firstly I'll take the difference of ARR of I plus 1 minus ARR of I, and let's call it division and say I'll do difference of this by 2, and I'll get the number of operations that will make them equal. Okay, and after this what I will do, I'll do int answer equals to division plus 1. These number of operation will make it equal but not desorted, and if I do one more operation it will make the array desorted. Number of operations that will make them make the array Desort. Okay, and I hope you get it. Okay. Now what I will do, let me define my solution here. Int solution. My solution would be equals to -1, and let's say my solution would be equals to, no, I want to find the minimum now. So what I will do, I'll do int max. Okay, I'll do minimum of solution and answer, right? And I'll check for one other condition, if my array is already Desort or not. If my array is sorted, in this I'll pass my vector and the size of it. If it is returning true, then I'll see out my solution, and else I will see out 0 operations. Okay, and here I will define my sort function. It will be boolean type, sorted. It will accept a vector of integers, let's call it ARR, and int n, and beside this I'll declare another vector of integers, let's call it temp, right? And I'll assign temp is equals to ARR, and I'll sort my temp dot begin till temp dot end, right? Sorry. And I will return if temp is equals to ARR or not, right? And if it is equals to ARR, which means that our array is already sorted, then it will return true, and if it will return true, then we will enter in this block, and if it will not return true, then we will enter in this block. This is a simple if else statement. So let's try to run it on sample test cases. And I hope this should work. Let's try to run it. Yeah, it is working fine. Let's save this and try to submit it on other test cases. Let's check if it is working on other test cases or not. Choose a file. My file would be in desktop. Desort1. Let's submit it. Yeah, it is accepted. It has been accepted. Yeah. So here you can see the code. Okay, so this much is the code. You can take the screenshot if you want, and I will see you in the next video. Thank you for watching the video. Till then, bye.